let's understand what is this reference variable. See, when you are using functions, when you use functions, generally you can pass the value. I think you are aware of these two types. One is call by value and the other is call by reference. Reference, or sometimes they call it as address, right? So we have these two schemes in functions. It means when you are passing a variable, if you are using call by value scheme, it means you are passing the value directly. If you are using call by reference scheme, then you are passing the address, right? So that variable we called as reference variable. When you are passing the address, we call it as a reference variable. It is slightly different from what we have seen. Let us try to see what is this reference variable. Let's just see this example. I wrote here, in generally I have x equal to 10 with me, this one x equal to 10. Then I am creating a reference variable for x, ref. It means both x and reference are pointing to same memory location. Both x and reference both are pointing to same memory location. It means address is 2000, for example. When x is 10, it is stored like this in memory, and the address let it be 2000. So this particular memory block, this particular memory box has a name, that is x. If you want to create another name for this, that is the concept of reference variable. Okay, what you do here, you will try to create a reference variable for the existing variable x. What is the syntax here? Data type, that is int ampersand reference variable. I am naming it as reference only, and the variable x. It means you are creating a, or indirectly if I say, you are creating a duplicate name or an alternative name for this x. Both will be pointing to same memory location. Either you use x or you use reference, it is same. But how do we define a reference variable? You have to give like this: int ampersand ref. Int ampersand ref, like if you see in this program here. Now see, in this example, I gave x equal to 10. So x is having value 10. Then I gave int ampersand reference equal to x. Syntax is like this: creating int ampersand x equal to ampersand reference equal to x. So I think you are aware of this. You can give ampersand here along with int, or you can give here also, right? So when you are creating a reference variable, you can use any of these schemes. Anyway, you can declare it like this. What happened with the second step? Another name is given as ref to this variable 10. Then you see, I am writing ref equal to 20. It means this existing, because ref is pointing to same location, x is also pointing to same location. I wrote ref equal to 20. When I write this 10 is erased with 20. Okay, so next I am trying to print cout x equal to x. So what is x value now? It will give 20. See, again x equal to 30 I wrote here x equal to 30. So what is happening? This 20 is being replaced with 30. Now when I print reference, say I am printing ref, this time it will give me 30. Indirectly, it's an alias naming, giving another name or giving another variable for an existing variable x. That is a reference variable. Okay, so we declare it by putting ampersand in the declaration like this: int ampersand ref equal to x. This is the syntax to create a variable with another name. Already x is there, you want to create a variable with another name. That is about reference variable. I hope it is clear. Any doubts, please let me know. Students, is it clear? Reference variable. Okay, right. So what now? Let us go to our next concept, that is difference between call by value and call by reference. You will let us little analyze. I know this is not new for you. You have already studied this call by value and call by reference. Okay, so see, call by reference means you are trying to, that is the significance of this reference variable. What you are doing here, you are trying to create another variable. If already I have int a equal to 10 comma b equal to 20 in a function like swap, if you are sending ampersand a comma ampersand b, if you are passing their addresses, then in this case, what is happening? Address of A and address of B is received. Okay, so this way also we can, you are swapping. This is call by reference. So here you are passing the address. Now, what if you create a reference variable for this A and B and send those reference variable? That is actually call by reference. Sometimes in some textbook they say there is call by value, there is call by address, and call by reference. Okay, both are not same. Address and reference both are not same. Okay, let's try to understand this. Why? Because what is call by value is very clear. We will see an example program. You will understand this much better. I believe you might have already studied that. So we were discussing about difference between call by value and call by reference, right? So see, let us see examples and try to understand here why we have to create a reference variable. Sometimes maybe you want to use certain variables for certain purposes. Okay, right? You want to have alias name also always for a given variable x. You want to have a different variable so that why this concept, that significance is available in this concept call by reference, because you see what is called by address. In call by address, we are trying to send the values. Okay, in call by address, we are trying to send the addresses. Swap ampersand a ampersand b, right? So a has some address 1000 and b has some address 2000. Okay, this is one way. You are passing here 100 and you are passing here 2000, 1000 and 2000. So the calling functions receive this address, then they point to these locations. Then those variables point to these locations. Whereas in call by reference, I will create for A and B, I will create a reference variable X and a reference variable Y. This I will be sending there. Let's see the difference here. Let's understand call by value. I will just quickly go through because it is not a new concept for us, right? So if you see this function, I have int main number equal to 5, increment number. I am sending the value directly with this variable. So this is call by value method. I am passing number here. So here another variable int num is created, and this num, why we are going for call by reference or call by address, you will understand it here. See, already you are creating a variable number. Again you are creating another variable num. So you are allocating memory for number and you are allocating memory for num, both. Why do we have to create? When it is holding same value, why do I have to create two memory blocks? For this declaration, it will assign 5 and some address 1000. For this declaration int num, which is received here, again it is receiving 5 and its address is 2000. So 4 bytes here and 4 bytes here. Unnecessarily we are creating 8 bytes of memory, which can be solved by only one 4 byte. That's why what is the drawback of call by value? Unnecessary memory creation, memory allocation happens for this local variable here. Okay, which is not encouraged. Why do we have to create another variable? Unnecessarily we are giving extra memory, right? That is one point about this call by value. Other differences, generally this number here, it is called as actual parameter, and this variable num is called as formal parameters. Actual parameter is this actual parameter and this is formal parameter. And we all know why. See, when number is there here in memory with 5, and we have another variable num with value 5. Its address is 2000 and assume this address is 1000. Now you see, we say one point. right? Any change you make to these formal arguments or formal parameters is not reflected in the actual variable. Why? Because this memory location is different, that memory location is different. You are making some change here, this value is not changing because the memory locations for both the variables are different. They are pointing to two different locations, 100, 1000 and 2000. That's why in call by value, any change made for these formal arguments will not reflect in the actual arguments. Will not reflect in the actual arguments. So this is a little information about call by value. So what is the drawback of this call by value? Unnecessary extra memory is created for all these formal variables, formal arguments or formal parameters. You are again creating to hold the same 5, 2 times you are creating variables. Okay, that is one small problem with this. Let us see call by reference. Okay, call by reference. Here what I am trying to do. Now what is call by address? Here only let's discuss. What change should I do in this program to make this call by address? Call by value is clear. Any doubt in this call by value? Students, please respond. I hope it is clear, right? Call by value. One drawback with this call by value is you are unnecessarily creating extra memory 2 times for storing a single number 5. Okay. Now, next one is call by address. What is this call by address? Here, when you are passing 5, you will be writing like this: increment, increment, you will be writing ampersand number. You will be writing increment ampersand number. It means address of number 5 you are sending here. Address of number 5 you are sending here. And here what change I have to do here? I have to write pointer int star ptr. Like this I have to write. When you are sending an address, ptr is a pointer which will receive this address. ptr is a pointer which will receive this address. Okay. So this is about call by address. Right? Call by value, we are sending the value directly. Call by address, we are sending the address. Maybe you were thinking we have only 2 things: call by value, call by reference. It is 3: call by value, call by address, and next we will see call by reference. See, in call by address strategy, I am trying to send ampersand number, and here a pointer is receiving this address and doing what all this stuff. In call by address, any change you make to this formal argument will be reflected in the actual argument. That is same with both the strategy. Okay. If you see about call by value, in call by value, we are sending the name of the variable. We are sending the value directly here. Number means 5. I am sending 5. This 5 is received in this new variable num. So num plus plus means num value becomes 6. And I am printing value as 6. Okay. In call by value, we send the value directly. That number we send it directly. Okay, we don't send anything else. We pass the value, actual value 5, we actually pass it. Okay, so any change you make in this formal variable, in this formal argument, will not be reflected in the actual argument. Why? Because see, you know the standard point, as whenever you define variables, memory will be allocated. When you wrote int number of 5, number and a memory block will be allocated with 5 and some address 1000. Okay, some address 1000, and you are passing this is fine. Here in the receiving function, again there is a defining a variable. You are declaring another variable, int num. So again one more memory block will be allocated, 4 bytes with name as num. Now what is the value in this? It is 5, because I am passing 5 here. I am passing 5. 5 is received. This address can be anything. Okay. Now, any change you make in this num, any change you make to this value 5 does not reflect here in this number, because this address is different, this address is different. So, they are not pointing to same location. That is one change, one thing. And the other point is that unnecessarily we are creating extra memory. Okay, which can be resolved using call by address. call by address. What is this call by address? Here you will be passing the address of the variable, right? Instead of this, you will write increment of ampersand number. You will write like this, increment ampersand number. So what you are doing, we know that there is a variable number, it has some value 5 and address is 1000. So you are passing address, that is 1000 is being passed here. So here you will have, instead of this statement, you will have something like this, int star ptr. It means the 1000 is received here. 1000 is received here. And it is star ptr means what is the value at 1000? 5. So if you write here ptr plus plus star ptr plus plus means this becomes 6. Now this variable ptr and this variable number are pointing to same location, same address. They are pointing to same address. Okay, so in call by address, what will happen? We are referring to a single memory location. We are referring to a single memory location, right? So 1000, it is always 1000 is being pointed here. Okay, so we are focusing about the address. So any change you make here in this function, that will be reflected here in the, because memory is same. When memory allocation is same for both the variables, or both the variables are pointed to same memory location, any change you make in the formal parameters will be reflected in actual parameters. This is called by address. Next, let us see what is called by reference. So just now we have studied about reference variable. How to declare a reference variable? That int ampersand referent equal to x. Int ampersand y equal to x. This is one way you can create a reference variable. It is just an alias, giving name, a name aliasing. Okay, giving another name to the same variable. So what is call by reference? Call by reference, if you observe here, same function, same program, number equal to 5, I am passing number. It looks like call by value here. It is call by value only because I am sending the value. But here you see, I am writing int ampersand n num. It means I am writing like this, int ampersand num equal to 5. I am writing it like this indirectly because number is 5. Number is 5. When this value 5 is received here, it means, this means any change. So we already had a number like this. Number like this. It was having 5, its address was 1000. When I send this, when I am creating a reference variable here, so for this number, another name is given num. For the same box, for the same memory location, another name is given, that is num. So this is almost same as your call by address. But the only thing, we don't pass the address here, whereas we declare a reference variable here. So there is a new concept, that is reference variable. Using reference variable, you are trying to perform the operation. So you are sending a value 5, one more reference variable is created for that function or for that variable, that is pointing to same location, same memory location. So you do. Now this is almost same as that. Only thing, writing code is different. How generally we have to write ampersand number like this. And here you have to receive using pointer. You have to write some pointer here. That way you have to receive it. But we are doing it reverse. We are sending only number and we are declaring a reference variable here. When you declare a reference variable, that is pointing to the same original variable number. And we have this value 5 in that. Okay. And when you do num plus plus, so both are pointing to same location. So any change you make here, that change will be reflected here. Okay, this is actual call by reference, but not knowing, we were studying, we were understanding that call by address and call by reference is same. I hope it is clear. In C++, call by reference means you will create a reference variable. You will be sending this normally, you will not be passing any address here, but you will be trying to create a reference variable. Okay, I hope it is clear. So this is about the difference between call by value, call by address and call by reference, right? You are trying to create a reference variable here. How to create a reference variable? This is the example of that. You have a variable int x equal to 10, then you are writing int ampersand some name equal to x. This is a reference variable name. So when you do that, You already had X with value 10 and some address 1000. When you write this statement, another name is given to this as REF. So whether you print REF, you get 10. Whether you print X, you get 10. Whether you change REF, this will change to 20. When you change value of X, this will change to 30. Anything you make, both will be pointing to same memory location. This is reference variable. So this is about the difference between call by value, call by address, and call by reference.